Yes, good afternoon, everybody. Um, Thank you for attending today. We're going to look at some soil sample analysis, different objectives, standards, guidelines, as you see on the screen there for the title. So just kind of give an overview of some different applications for soil sampling, things that go into it, what we look for analysis, different contaminants of concern and where those might pop up, and when we should be concerned and look at sites either on the investigation side, remediation, or both, or possibly just looking at soil to make sure it is clean fill before we use it for backfill and such. So we'll get into all that today. The next, just going through. All right, so I'm not going to go too much into the ground rules, 100% participation, all that stuff that Jordan went over. So um, if you're good there, we'll jump right into it. All right, so just to set the stage, give you a little bit of background on what we're going to discuss today. Mainly, we're going to focus on soil. There's a lot of different media out there that you could do sample analysis for on contamination, whether it be soil, groundwater, air, sediment type materials, and they all have their own individual intricacies with them and different rules, regulations, guidelines. So, but today we're just going to mainly focus on soil. We only got the hour, so we'll just talk about soil today and get you some information on that. Also, just want to point out that we're just going to be dealing mainly with chemical contaminants. Those contaminants are concerned man-made type products, or some are naturally occurring, but things that contaminate properties that you might be concerned with on the soil sample analysis side of things. Not necessarily going into things such as the quality of soil, nutrient value, things that you would look at as far as seed germination, planted grass. My wife just got a red maple sapling last year and replanted it. It's not looking too healthy. So if you're looking for something like that, you might want to talk to someone else on that. But today we'll just focus in on these chemical contaminants and go through some different items on that. And then lastly, just want to make you aware that we are dealing we're dealing pretty much with New York State regulations and guidelines. So some sections in our discussion today will be focused on a little bit on regulation guidelines that are out there, and it is pertinent to New York State. Not to say that some of this, there is a general overflow of stuff into other states. Similar things would be done in other states. They're just going to have their own sets of regulations and guidelines that you'd want to be aware of if you're working or if you're doing things in those states. All right, so just to look at what goes into soil sampling, some fundamentals, some different items we would look at that might dictate or direct or guide us as we're doing sample analysis, why we would want to do it, how we're going to go about doing it, what the end result should be, or what we look to achieve with the soil sampling. So just taking a look at a few fundamental items is, first off, soil types, characteristics. What type of soil are we dealing with? Is it a clay or a fine grained soil like a clay or a silt? Or is it more of a coarse grained soil getting into a sand, or even further with larger particles getting into a gravel material? As far as doing sample analysis, that's going to be important to know. If we're looking at a contaminated site, a clay silt material might, should slow the migration of contamination. So, it's beneficial maybe to have that type of material in your area of concern, because you could have a lot less of an area that's impacted with those types of soils. You get into a sand and gravel, it's going to be a lot more loose, a little bit more voids in those, a little bit easier for groundwater to migrate and carry contaminants with it. So, we do like to pay attention to that, make sure we know what type of soil we're dealing with. That kind of helps us gauge how to go about determining the extent of contamination. And then into the remediation, there's different factors that might come into play based on the soil type that we are dealing with. And then looking at the soil properties itself a little bit further into details, color of soil, moisture content, density, odor, those types of things. So as we're looking at soil, obviously if there's some visual staining or a characteristic odor, that could give us, definitely some information that, yeah, we might have a contamination issue here, and then kind of direct us. So we're not necessarily sampling a lot of the materials. We can collect multiple samples, give it a visual, odors, check to see if we know that it is contaminated based on that, without having to do excessive amount of analysis later on. We can limit the analysis a little bit based on those initial field classifications. But looking at moisture content, again, groundwater conditions, those may help to transport contaminants along the site, on the site, or even off the site. So, it's definitely important to know, whether we're dealing with a situation where we have soil above or below the groundwater table. So that helps guide some investigation and remediation planning. So, not that we're going to get too much into groundwater here, but just knowing that, that will help direct some of that field investigation for soil sampling. So some other things, sampling areas, what are we looking at sampling? So are we dealing with stockpiles? Are we dealing with in-place soil, in situ soil? Or are we doing this as part of an excavation area where we want to sample excavation, see if, we're into clean material, if we're doing a remediation type project. But, that's going to help dictate how we go about the sampling. Obviously, if we're dealing with a stockpile, and we're sampling the entirety of the stockpile, we got a good idea. We can see it. It's right there in front of us. We can break up the samples, get a good representative composite sample pretty easily. Then you go into in-place soil. Okay, it's a little bit more challenging because we're going to probably have specialized equipment to sample that. If you're doing shallow samples, maybe you can hand dig those samples, hand auger or something to that effect. But when you get into the deeper depths of area of impact, or if we're assessing a deeper depths of material, we're going to be bringing in drill rigs, geoprobe type systems, direct push sampling to grab those samples. So a little bit more in depth with trying to get that done. You could also do some test pits for in place, but you got to weigh the benefits and consequences of doing some pretty destructive sampling versus a little bit extra there, and have minimal disturbance to the site before we do anything further. So some different things that come into play depending on the sampling area. Then looking at, you don't want to go into a site and just go into a site blind and just sample wherever, especially if you're getting into a larger size properties. You want to kind of have a target for what you're sampling. So identifying areas, concerns, potential contaminant sources. Then you can get a more focused sampling program going based on that. If you're dealing with mainly a soil that, you're just kind of trying to maybe reuse it for backfill. Okay, how much of that soil is going to be excavated? What depths might you be excavating? All that will come into play in limiting, the area of investigation to make sure we get the best available data for the purpose of that sampling event. Also looking at developed versus undeveloped sites, sites that might have historic fill versus sites that are pretty much untouched. Obviously, if we're on, a soil that we know has never had any disturbance, no prior development, usually there's not really anything required for the sampling analysis. But when you get into those developed sites, you not necessarily know history of things. You suspect, things that may or may not ever have occurred, or just the development in general. If it was industrial site, commercial site, residential, that will help guide the sampling program as far as what might be the areas of concern, how much sampling you should do, and the analysis that you might want to do with that. All right, so then a few other things on soil sampling fundamentals. So, type of sample, a lot of times we're either looking at a grab soil sample or a composite soil sample, pretty straightforward. A grab sample is something that's specific point, specific depth interval. We're not, combining different locations or sampling depths into one sample. We're just getting that point and location type sample, whereas a composite would be, mixing a few locations together, get a better representation of the location or area you're sampling. Both of them have their benefits and drawbacks, and depending on the application, you're going to choose one or the other. Composites are nice if you're looking to get a lot of, a little bit more information, a bit more coverage, but a little bit less costly on the analytical program. You can do some composites there, whereas grabs could give you a little better information as far as, okay, is there any specific point that where we might go above regulatory standards? You don't want to dilute down a sample by composite in that scenario. You might want to get your worst case scenario, see how high those contaminants are, and then that'll kind of identify whether you got a significant problem where you're going to have quite extensive remediation, or if it's pretty minor and you might be able to handle it with a little less activity on remediation. Sampling equipment's important, for personal protective equipment. Not only do we want to make sure the samplers are well protected and not being exposed directly to these potential contaminants, but also for the integrity of the sample. We don't want to not have PPE and then we're cross contaminating different samples, and then you kind of you'd have your data would be in question as far as whether it's really that sample that you collected, or maybe there was some cross contamination. So definitely want the appropriate PPE for the sampling. And then going into those collection tools, selecting appropriate tools, things that are either disposable sampling tools where one-time use, collect your sample, dispose of it, you're good to go, or something that you can decontaminate easily, so you don't have that cross contamination from the tool. So different things you can use if you're doing manual hand sampling things, shovels, trowels, hand augers. Then you get into more of the extensive drilling operations where you might have stainless steel core samplers with liners inside them. So that helps to keep your individual samples in disposable liners with an outer stainless steel macro core or core sampler that you can decontaminate. So all those things will help to keep your sample integrity intact and not have to worry about the cross contamination issue. Then going into sample handling management, so the containers you select are going to be specific to analysis you're doing. Some are going to have preservatives to make sure that you are able to collect the sample and get it to the laboratory and have that sample stay in good good stand and good status before it gets analyzed. And there's going to be hold times depending on analysis as well. So you don't want to extend over those hold times, because again, you're going to have sample data, you're going to have questionable sample data. If you get to that point. So paying attention to all that, making sure everything's on the up and getting good quality data when you're doing the sample analysis program. Of course, chain of custody, we want to make sure that the sampler has full chain of custody procedures from the time they sample right on through to delivery and analysis, so we know exactly who was handling those samples through that process. All right, so now we'll jump into contaminants concerns. So as I mentioned earlier, we want to look at chemical contaminants. What things, a lot of these things are, things that we've, produced industrial processes, manufactured goods that, eventually if not handled or managed properly, they can leak out, spill out, contaminate the environment. So a lot of these are those types of things, whereas you might have some naturally occurring things, metals, cyanide, where not necessarily something that we're introducing on a certain specific process, but something that in great enough extent could be harmful to the environment and wildlife and people as well. So just this is kind of like a full suite of, if we're to someone was to ask, can you do a soil sampling for contamination? This would be, the typical full suite that you would do: volatile organic compounds, semi-volatile organic compounds, pesticides, herbicides, PCBs, the polychlorinated biphenyls, metal cyanide, and then our newest member here, the PFAS, per and polyfluoroalkyl substances. So if you're kind of looking at a site for general contamination, do we have clean soil or not? These are the analysis that you typically go ahead and do, and covers quite a bit of what we have out there that are issues with contamination. So we'll look at each of these a little bit more in depth. So as far as volatiles, semi-volatiles, your VOCs, semi-VOCs, where do these things come from? Well, these are the things that, they've got carbon, hydrogen atom in different conglomerations, different mixtures, chemical makeups, but ultimately used for solvents, cleaning chemicals, petroleum products, a lot of different things out there that we use every day that these help to manufacture and produce. So quite a bit, as you can see, there's quite a bit of things out there. Personal care products, building materials, caulks, adhesives that have VOCs, semi-VOCs. Now, a lot of times, if you have a building material or some sort of material product and it gives off an odor, a lot of times that's something to do with VOCs. It's volatilizing off. So that new car smell that you get, that everyone likes to, oh, nice new car smell. Well, that's really some volatiles that are off gas in there. So not so great, even though it might give you a nice little reassuring feeling. A new car smell. It's not so great in the end there. So a lot of things that the VOCs are coming from. Big one in contamination, petroleum products, obviously. So petroleum products, usually when you're doing an assessment or investigation, cleanup of those, you are dealing primarily with those VOC, semi-VOC compounds. Then get into pesticides, pesticides being a substance used to kill, repel, or control pests. And those could include herbicides for plants, insecticides for insects, fungicides, so on and so forth. So these, obviously something that's used to kill, something that's living is probably not going to be very good to human health or other wildlife and such. So, limited use is practical use is beneficial. If you can get away with not using it, that's even better. But, you do have those, those trade-offs with, the value of using these for crops, make sure that we have, good crop yields, make sure we don't have weeds growing where we don't want them or don't need them. But there's a trade-off. There's, potential consequences if there's overuse of them and potential contamination of surface waters in the area, soil, and such. All right, then moving into PCBs, our polychlorinated biphenyls. The good thing with these is they are banned. 1979, they were banned for the production and use. So a lot of that equipment has been phased out or is going to be phased out eventually. There still are some, I'm sure there's still some older type materials. Some older building materials too. Unfortunately, it wasn't something that we just limited to the common things that started with PCBs, dielectric fuels, oils, things like that. It trailed off and found its way into some other materials and products, light ballast, paints, coatings, caulks, adhesives, and other building materials might have those, printing inks, plastics, even carbonless copy paper. So problem with PCBs, it's one of those chemicals that it's very difficult to break down. So it's one of those long-lasting chemicals out in the environment. So if it gets out there, pretty much limited capabilities on remediation other than removal, or you got some incineration type processes to get rid of them. But definitely one of those that unfortunately, by the time we knew it was an issue or a concern, the cat was out of the bag, and it had been affected a lot of different areas. So one that we would assess depending on the application, use, or historical development of different sites. All right, then we get into metals and cyanide. So these are the ones that not necessarily are things that are totally man-made, but they are, as they are naturally occurring minerals, but they can be exacerbated based on different activities that are done in our modern world, industrial type activities, mining, smelting, metal electrical plating, manufacturing, different things like that. Waste disposal, whether it's from those industrial activities or other things that have high metals concentrations, disposal of those. Automotive emissions is a big one, especially with the lead. A lot of surface soil in urban areas have a high lead concentration because of the automotive emissions from past use of leaded gasoline. So definitely concerned with those there. Moving into urban runoff, so the higher amount of development, the higher amount you're probably gonna have metals in different things that can run off stormwater, surface water areas. Agricultural runoff from pesticide fertilizer use, and then building materials. We all know about lead-based paint, but they could also have other metals in different building materials. Mercury has been found in some different foreign type materials, and you can chromium and has been found in paints as well. So you can have different materials, different metals. So definitely, something to be on the lookout on that. And then, as I mentioned, the newcomer, they hear the PFAS, the emerging contaminants. So again, it's kind of similar to your PCB, something that, we used in a lot of different products. Didn't really know the harm or risk until it was too late. So now there are a lot of sites out there that do have PFAS related issues. Similar to PFAS, very difficult to break down, probably even more so than PCB. So definitely a concern now and moving into the future, trying to get different sites that have a lot of PFAS contamination cleaned up. Definitely something you don't want to get into drinking water supplies. So, the faster we can get ahead of that or get control of it, the better. A little bit different from PCBs, whereas PCBs were banned. PFAS are not totally banned as of yet. There are different states. And federal has some things out there that limit, that do certain bans, like New York State. There's a ban for purchasing new clothing or the sale or manufacture of new apparel with PFAS. So making steps towards pulling this out of different products and making things better as we go forward. But there are still instances where PFAS are used and implemented. So still going to be dealing with this for a while yet. But as you can see, some different materials, firefighting foam. So a lot of areas that use those firefighting practice, they would use those foams, and there's quite a bit of contamination out there from that. Then you get into cleaning products, water resistant fabrics, so those waterproof clothing, definitely had a fair amount of PFAS in those. Grease resistant paper, nonstick cookware, personal care products, even stain resistant coatings, sunblock, sun spray, historically had some PFAS in there. So it definitely found its way in some different products, and not so great for human consumption or human contact. All right, so what are our pathways of contaminants to soil? So we're kind of looking at the soil question. How might soil be impacted by these different contaminants of concern? So, first off, direct application. Ideally you don't want to just apply a contaminant right to soil, but it happens, especially with the pesticides, herbicides. We are applying those to control weeds and pests and different things. So you do have that direct application source there for that type of scenario. Then you get spills, leaks. That's probably the more common item of what might contaminate. Okay, we have petroleum products. We have some sort of product, solvent, chemical. As long as it's intact, as long as it's in a storage tank, as long as doing where it's intended to be, we're usually in pretty good shape. But things happen. Equipment fails. We have human error, overfills, things like that. So we get those spills and leaks. So definitely a pathway to soil from there. Weathering of materials, more so with your building materials. So if you have those lead paint, exterior type materials that have different things, asphalt, freshly laid asphalt, you get rain on it, you're going to get some contaminants, probably washing away semi-VOC type contaminants. So definitely the weathering of materials could be a concern there. Waste deposition, illegal dumping of materials, improper handling of your waste. It doesn't go to a landfill that's lined and contained and all that. It goes somewhere else. That becomes problematic. That's why we have regulated landfills now. In the past they weren't as stringent on those, and definitely had some issues that came forth from those. But obviously anything currently, if people are doing illegal management of waste, that could be a source to contaminants to soil. Groundwater migration, surface water runoff definitely could spread contaminants to different locations. Airborne deposition, so like I mentioned, those automotive exhaust with lead, so that'd be something that goes up in there and then it comes down, settles down, then lo and behold you got some elevated levels in your soil. All right, so moving into analysis. So went over a little bit of the sampling stuff. So about the analysis, different methods for the different contaminants of concern. In New York State, we do have a environmental laboratory approval program through the New York State Department of Health. They will review and approve methods that can be used for analysis on sites in New York State. So any of those analysis, especially the contaminants that we are talking about today, they will have ELAP approved methods that are implemented. So you know when you send it to a lab that there is some standard of practice that they have to adhere to for those samples to be analyzed. A lot of the methods are also they're EPA approved methods. So you might hear EPA method 8260, that would be for your volatile organic compounds, EPA method 8082, that'd be for your PCBs, and so on and so forth. So they all are all EPA approved methods and ELAP approved methods there as well. So just getting into a little bit of specifics on the analysis. So different methods, common methods out there: gas chromatography, mass spectrometry, liquid chromatography. So these are different methods, or they're combined together to get you to where you want on the data analysis. ICP, AES. So not going to get into too much detail of that. You know, some sophisticated equipment out there that they do use to get these samples processed and analyzed. It's you know, quite a bit goes into it there, but you know, at the end of the day, you're getting results for, you know, compound specific type results. So when we're looking at VOCs, we're breaking it down right down into different compounds: benzenes, toluene, ethylbenzenes, a lot of different things that are detected and analyzed. So pretty neat how you can take a sample and get those results from those. All right, and then we move into, you know, when we're dealing with soil, you know, obviously with historical development, historical construction, demolition type activities, you could get a situation where you have some different types of materials mixed in with your soil at a site. So the non-soil constituents. And some of these aren't, you know, aren't the end of the world if they are in your soil. So you get some different construction, demolition debris, bricks, glass, asphalt, metals. Not always are you having to remove that soil and dispose of it. There are different avenues that you could reuse that type of soil. But when you get into some other types of waste, you know, listed here, like the plastic, gypsum board, paper products, things that may readily degrade or produce odors, or in asbestos material especially, those types of scenarios where you have that mixed in with your soil, you're probably going to have to get those disposed of somewhere. Not a good reuse for those for many different factors. But you know, if it does have a waste, you know, and generally when you remove soil from New York State, it is considered a solid waste until you can prove that it meets some beneficial use determination. So you know, basically waste being something not intended for its original purpose. So as you excavate it, if you do have a beneficial use for it, great. We don't have to fill up a landfill with that, but you know, if you are mixing in these types of materials, you're looking at a disposal condition on that. Okay, so some different soil sampling objectives. I like to throw these into 4 different categories, one being risk assessment, site investigation, site characterization. So we're basically looking for a site. Sometimes we know there's contamination. We're trying to delineate that, identify those areas that may need a remediation option. Or it might be a site where we have some areas of concerns where we don't really know what the conditions are, and we want to kind of investigate those area of concerns. So, you know, that would all be in this category of risk assessment, site investigation, and characterization. And then you got the remediation confirmation. So we're doing remediation at a site. We want to take some soil samples there to confirm that we are beyond the limits of the remediation. We did the satisfactory cleanup, especially if you're doing something like a soil removal, excavation, and then disposal, and then putting a new backfill. You want to make sure you got a nice clean area, or at least you're below the regulatory standards before you do those backfill operations. So there'd be that category of soil sampling for that cleanup confirmation. Soil reuse, so this would be anything, you know, if we are excavating soil and we plan to use it at an alternate site, or we're bringing in imported fill as backfill for a site, it's good to have some soil sample analysis on that to make sure we have a good material that we're putting in, and we don't find out down the road that we placed contaminated soil at a site. So good to get that sample analyzed beforehand. And then finally, waste characterization. We know we have soil that's, you know, can't be reused, it's contaminated, we don't need it, we don't want it anymore, we're going to take it to a landfill. landfills do have criteria and protocol for sampling and analysis of that waste to make sure that they are able to accept it, whether it's hazardous or non-hazardous waste. Know the conditions of it before they can approve the receipt of that material. So we'll go a little bit more into each of these, but first wanted to take just a little step back and just kind of go through some different things with sample analysis and evaluating the analytical. So when you're looking at sample analysis program and analysis results and what we compare those to, you want to kind of look at, what's out there for regulatory standards. So these will be things obviously that, are written in regulations, law that, we should be complied with. And you'll see these kind of designated by these nice acronyms, the NYCRR, so the New York Code of Rules and Regulations, and or CFR, Code of Federal Regulations. So here's some that are pertinent here in New York State. So Part 360 would be or fill. They have, segments of that regulation has fill material sampling. So an analysis criteria that kind of describes how you would sample fill material before you reuse it and what standards you would comply with, which it does allude there to the Part 375. Part 375 we'll go over a little bit, but that contains a lot of those soil cleanup objectives that we're striving for. And then again, the Part 764, 40 CFR Part 761, that'd be the PCB mega rule. So there's some things in there about sample analysis of PCB. 40 CFR Part 261, hazardous waste regulation. So that'll help you with, sample analysis for hazardous waste determination. But in addition to the regulatory standards, there's guidelines. So these aren't, specific regulations that need, full compliance with, but more documents that help guide those sample analysis programs. It gives a little bit more instruction and guidance, a little, less law-like, more, assistance with that as far as dictating or helping you decide or determine these sample analysis criteria. So not specifically a regulation that needs compliance, but usually they are written into the form that a lot of times you're going to follow those, and that'll get you to compliance. That'll get you to a good end result with your sample analysis. So, Commissioner Policy 51, CP 51, Division of Environmental Remediation, DR 10, STARS 1. These are different documents that help guide those sample analysis programs. All right, so soil cleanup objectives. So these SCO, a lot of acronyms in the soil sample and environmental in general, but the soil cleanup objectives, 6 NYCR Part 375. These are the regulations. So these would be the things that you would need to comply with if you're doing an environmental remediation project. So you want to make sure at the end of the day, we're going to be below certain standards, and those are all going to be in that Part 375. There's also supplemental soil cleanup objectives, and that's more in those guidelines, the CP 51. So some things that have been added after SCOs are established in Part 375. Again, it's in the guidelines, but it's one of those where you're looking to have compliance with those as well. There's enough information out there on those target compounds that you're going to want to get below those if you can. That's safe for the environment, better for the environment anyways, better for people and all that. So when we talk about these cleanup objectives, there's different types there. One being unrestricted use, so pretty much you can use it for any type of site. That's the gold standard. That's where you want to be. If you can get below unrestricted use objectives, that's where you want to be. There's certain sites where it may not be practical or feasible to get to those, where you'd have more restricted use objectives, whether it be on the residential, restricted, residential, commercial, industrial. So as you can imagine, different type of site, depending on what type of use that site would be developed for, you would be working with one of those standards on that. This generally includes, when I went through those full suite of compounds, those generally include your VOCs, semi-VOCs, metal cyanide, PCBs, pesticides, and herbicides would all have these types of objectives. They would be applicable to remedial programs as stated in 6 NYCR Part 375. Also, your Part 360 regulation, where it talks about fill sampling for reuse, those predetermined beneficial use, they do defer back to Part 375. So you are looking at compliance with those standards on fill sampling for reuse. And then in general, if you're doing any type of site investigation characterization, it's good to use these as a standard for comparison, because ultimately you may have to go down that road, for a remediation or a fill reuse scenario. So always good to have these there for comparison, regardless of the type of sample analysis program you're doing. All right, so moving into the PFAS, where we don't have those in the standards currently, but there are guidelines out there. So New York State DC does have a sample analysis and assessment for a PFAS guideline out there that does have soil objectives in their proposed guidance values for that. There's also out there currently a draft revision for CP51, which includes these PFAS guidance values as well. So there, you can see those up there. Eventually, it may trickle into the regulations, but for now, it's been determined that it would be put into the CP51 guidance policy. All right, so hazardous waste, we got something that we know is being disposed of. What do we have for hazardous waste characterization? So there's 4 criteria you want to look at as far as hazardous waste characteristic. One being if something's ignitable. Now, obviously, we don't want that going into a landfill situation. If it can spontaneously ignite, a regular landfill is not equipped for that. You can have quite a mess on your hand. That should be going to a facility that can handle and treat and dispose of and manage those materials. Similarly, reactivity, something that might react harshly with, water, other products. We don't want that in a regular landfill. Again, people, those landfills aren't set up to deal with those or manage those or have those in place. So that has to go to a special hazardous waste type facility. Corrosivity, anything that might, be corrosive in the environment, we're going to have to treat that special. And then the final category, the kind of more encompassing one, the toxicity. This could get into where those other contaminants, if you have a high enough level of volatile organic compounds, semi-volatiles, metals, pesticides, or if you have a high concentration of PCB, so New York State, PCB above greater than or equal to 50 parts per million, these will all be classified as hazardous waste. And you would want to determine this before you decide on the facility that these materials will be going to, because if it's waste that does end up being hazardous, it can't go to one of those normal, regular, typical landfills that we have throughout the state. You'd have to take it to a specific facility. So getting that sample analysis done up front and doing the waste profile and making sure everything's going to the right place. All right, so just going back to those 4 different categories, I looked at just a little bit more on those. So the risk assessment, site investigation, site characterization. So different things, you use these at spill sites, tank sites. So if we're closing the tank out, before the removal, do a site characterization, make sure everything looks good, no contamination from that tank, then we can remove the tank and get the site back to a different development or use. Areas of concern from phase 1 environmental site assessments. So, go out, do an assessment, see different things that might raise a concern as far as past historical potential spills, potential development, potential tanks. Those things could be investigated on that up front. A lot of this is centered around making sure, if it's a property transaction, making sure things look good before that deal is done, or if it's a site that had a prior spill or a current spill, just kind of looking at those things, seeing what the condition of the site is, seeing what the extents of those contaminated materials are, so we can get a good remediation plan put together. So with that, you're kind of looking at those Part 375, the soil cleanup objectives, CP51, DER10, some of those things would work, would be used in concert with this type of soil sampling application. Remediation confirmation, so site remediation, spill cleanup, whenever you're doing that type of activity, you're likely going to want some soil sampling, see how things are going. If it's an interim remedial phase, see if things are improving, or if it's towards the end, final remediation, make sure everything does look good. You're below the standards or below the target concentration that were selected for the remediation. And you're looking at similar type as the site characterization, Part 375, CP51, DER10. Those would all be pertinent. One thing with DER10, they do have sample and frequency, so this helps guide as far as how many samples you should collect. So there's different information in there, a couple things in there, imported uh, soil or soil exported from a site. So this kind of goes through how many yards you're dealing with. This would be the minimum samples you want to collect, and then you have the difference between this discrete grab samples composite and one analysis you're going to do on those. So a lot of that's going to be guided by those guidelines to give you a good idea how many samples should be collected at a minimum. And then into tanks, this helps you determine, depending on the size of the tank, how many in the length and how many samples you want to look at collecting there. So out of this DER10, VOC, semi-VOCs, metals, cyanide, PCBs, pesticides, herbicides, and also looking at the PFAS. The PFAS guidelines have implemented that DR projects, Division of Environmental Remediation Projects, should include the PFAS analysis with any sampling that's done. So soil reuse assessment, so backfill, you're bringing backfill into a site, or you've excavated soil from a site and you want to reuse that. It's always good, get that stuff sample analyzed. You don't want to create a problem somewhere else if it's a problem at your site, so make sure you do a good assessment on that. Site cap, soil cover. So if you're doing a site remediation, you want to make sure if you're putting a site cap or soil cover over it, that's nice, good, clean material. No sense capping contaminated material, more contaminated material. So you do this type of sampling and analysis to verify that. And then from there, the Part 360 regulations do have things that break it down to different fill types. And depending on what fill type you fall into, that'll help decide what the end use of that material could be for. So very useful to kind of guide as far as, you may have some contaminants in there, but there might be some uses still for it that you can implement. And then Part 375, CP51, Part 360, DR10, a lot of that will help on the soil reuse assessment. So here's similar to the DR10, 6 NYCR Part 360. So that fill material sampling, it has a similar table as far as, quantity of material, how many samples minimum you should be collecting for the reuse evaluation. Now this is a little different. PFAS isn't specifically referenced in Part 360. Still probably a good idea to do it, especially if there's a concern at the site you're looking at. But in general, PFAS or the Part 360 really only references compounds listed in Part 375, which currently does not include those, but does include all those other ones that we've been discussing. All right, and then waste characterization. So landfill criteria, what does the landfill require? That's a big critical indicator, but you also want to kind of make sure that, even if the landfill may not require it, it might be a concern to you, maybe get it analyzed anyways, because at the end of the day, the generator, whoever's generating that waste soil, they still have responsibility for it. So, maybe you don't feel comfortable with the minimum landfill standards. Maybe you want to go a little bit above and beyond, which is perfectly fine. But each landfill is going to have their own set of criteria that if you want to take it there, you will have to comply with, or they won't accept it. So good to know what the landfill wants or needs. With this, we're looking at record hazardous waste characteristics, which I went over those 4 characteristics there, and then with the toxicity characteristic leaching procedure analysis. So kind of looking at if we were to put a material in a landfill situation, what's going to leach out from that material. So that TCLP analysis gives you that sort of assessment. And 40 CFR parts 261, that hazardous waste characterization will apply there. All right, so like I said before, sample frequency and parameters for waste characterization, disposal facility criteria, but the generator does have responsibility to ensure they provide accurate information about the waste. So they're going to be ultimately responsible for making sure they know what that waste is, what there might be in there, and they do analysis maybe above and beyond what the landfill may be requesting if they feel necessary. And then going into sampling plans. So, you don't, like I said, we don't want to go into sample analysis blind. You want to have some sort of plan going in, regardless of whether you're just initial characterization of a site, or if you got a remedial site that you have specific, criteria as far as how many samples you have to collect, where you have to collect them, when you have to collect them, and all that. But it's good to have something agreed upon. And this might be like in an initial investigation, primarily a written scope of work and a proposal or contract. But it should be something that's there that between the sampler and the owner and other parties involved that they're agreeable to. It's going to meet the objectives. It's going to meet the goals of what you're sampling for. So get that in writing, get something there that everyone can understand and relate to. Other things, you have adherence to regulations and requirements of regulatory programs, so make sure that's in your sampling plan. And that might include sample analysis plan, site characterization plan, remedial action plan, or a quality assurance project plan, combination of these different plans. So making sure you have all that written out in there, depending on the end use and what is required for the site or project. All right, so just lastly, just kind of throw this out there. There's always, standards, regulation, guidelines. They're always tend to be updated from time to time. So there are some different things out there that's ongoing. 6 NYCR Part 375. So those standards that have our soil cleanup objectives. There's a revised rulemaking in process. So some different SCOs, different soil cleanup objectives will be changed on that. So that will affect, projects in the future. They'll have different regulatory soil standard values to comply with there. And then the New York State, concurrently here with the New York State DEC CP 51 guideline or commissioner policy, revisions are in process. So there's guidance values for those PFAS, the PFOA, PFOS will be added there as I showed on that one slide. Updated PCB guidance values consistent with EPA cleanup criteria, and some other updates to supplemental soil cleanup objectives. So definitely some things out there that are currently going on. In the future, there could be additional changes later on with different rulemakers and such. But, in general, how does this impact, soil sampling and analysis going forward? Well, or, going back, for the most part, anything that was remediated under a previously existing standard, that's going to be good as is. But you do have to kind of keep in mind that, if there's property transactions and someone wants to investigate a site, whether it was previously remediated or not, you're going to be looking at those soil conditions to the current standard. So maybe it was remediated and determined to be below previously existing standards, but if you're doing that type of investigation, it might come up above those standards. So then, you kind of have to evaluate that. And again, that's a property transaction type scenario. So, are they comfortable with past remediation that has occurred, business type decision there. So, but going forward, definitely we got the two ones currently going on, and then there'll probably be some future ones, I'm sure, down the road with different that might affect soil cleanup objectives or soil standards and policies.